There we go. All right, how's that? Awesome. All right, so yeah, my name is Maxime Lamothe-Brassard, or Maxime Lamothe-Brassard. So if you have questions in French, it's all good. English, obviously, is also fine. I work at Google in Mountain View. However, this talk is, my views are my own and not my employer's, a usual disclaimer. So LimaCharlie, open source, cross-platform, automated EDR. So that's a lot of things in a row, but I'll just introduce it. So the first thing is, well, I bet most people here have started to look at an EDR. So EDR, just to be sure everybody's on the same page, endpoint, defense, detection and response, that's the one. Essentially some endpoint solution, right? So everybody's looked at that and they decided to put their hard-earned money into some EDR. And I bet one of the things they told themselves is, damn, I wish this wasn't so expensive. So that's a very fair point. Now, maybe you bought that solution and someday you actually get a detection out of it, well, hopefully. So it detects something. And then let's say it's some kind of like PowerShell-based, bad malware. And all you get is some kind of process tree. And you go, cool story, bro, but this is really not helping me all that much. I really, really wish that I could actually have more context about what it's detecting so that I could actually respond in a better way rather than having some kind of spoon-fed, here's what you get. Finally, well, maybe you're lucky and what you have is one of those next-gen EDRs. So what it means is that it hooks in VirusTotals and you can download files. So you actually do decide, okay, I'm going to get that PowerShell file. And you sit down in your console and you say, okay, I want to get this file from this computer. And if you're really, really, really lucky, you're going to get it in 5 minutes. If you're not so lucky, maybe you'll get it in 6 hours. Now, this is really a big problem because if it's malware, if it decides to delete itself, if something's actually attacking your system, the last thing that you need is to be able to respond 5 minutes later when everything might be just over. So I just wish I didn't have to go and do this manually. If there's something bad, there's some things that I'm always doing when I'm responding to this, and maybe getting the files, one of them, maybe getting the files that it touched is one of them, maybe getting the domain names that it accesses is one thing. But I just wish I didn't have to do this manually because this is just a waste of my time. It's the most boring part of the job. You want to get everything that you need, and then you can actually start and go hunting. I wish I could also do some searches. So here's a scenario. Some organization, let's call them maybe RCMP, comes to your door and says, hey, we think that your company might be owned by some piece of malware. Maybe it's some other regulatory organization. They come to you and they say, hey, we think there's some piece of malware. And in that report, they're going to have some maybe domains, maybe hashes. And that's cool, but maybe they have more. And really, what you'd like to do is to be able to go and look historically on your network, because today, maybe they're not on your network, but maybe they were there yesterday. And most tools, yeah, will allow you to search by hash. Great. But there's a lot more to hashes to security. So I just wish I could do more than just hashes. I wish I didn't have to wait for the vendor. I'm looking on some blog report online about some crazy new piece of malware, and I'm thinking, holy shit, is this on my network? And then I look, and my EDR vendor doesn't support it yet. And then I just have to sit back down and take my cup of coffee and wait for a couple of days because hopefully they'll fix it. Why can't I actually codify and actively look for what I want to look through my EDR? Why can't I actually leverage really this really good tool? So that's all the reasons why LimaCharlie was created. It's an open source EDR. So when I say open source, it means Apache v2. So you take it, you do what you want with it. It's cross-platform. So no using different tools for all the different platforms and different UIs and different frameworks and different capability. So this is Windows, OS X, Linux. Linux, your mileage may vary. You might have to compile it for whatever flavor of Linux you have, but it works. Automation through community and internally. So Some tools may be provided by a vendor will give you some really interesting piece of automation, but that's what they provide to you, and you're going to use it, and you're going to like it. But sometimes you want to develop it internally, but you might want to also start sharing it externally. So that's also a critical part of LimaCharlie, the ability to take those detections that you generate, the things you look for, and the automations, and share them outside. Scaling, yeah, that's quick. It's horizontal scaling, sure, whatever. Bidirectional real-time is actually one of those really, really, really big deals. So that means you're not reacting within 30 seconds, not 5 minutes, but in real time. So the sensors of LimaCharlie allow you and your automations to interact with the sensor live. So it means that when the sensor detects that there's some kind of code injection in the system, or something's executing from somewhere it shouldn't be, your automation is able to respond in a live fashion. And we'll get into details about what that live means. Integrations, yeah, it integrates with a bunch of stuff. It outputs to Splunk and CEF and all this good stuff. This is a quick one slide. I won't spend much time on this. This is kind of the architecture. Essentially, you get a backend. That's what scales. You either run it on your own hardware, or you run it on some cloud provider somewhere. You have your sensor. It's cross-platform. And the sensor connects to the cloud over a persistent connection, which is what gives you this live response, and wherever the sensor is. It's not just on your LAN. It could be a laptop from your CEO that decided to bring it to China because it's a great idea. So some sensor capabilities, very quickly, there's a lot of stuff. All the green stuff is essentially what the sensor will generate on its own. Those are all events about things that are happening. So we generate quite a few of them. It's really the usual suspects for EDR, and then a couple more that are kind of interesting. The orange ones is, hopefully you can read, so the orange ones are things that are kind of running constantly in your sensor. So you can do things like detect injection, hollowing, or do consistent Yara, so if you have Yara signatures, over all of your endpoints in memory and on disk at all times, just with QoS, so you don't spike your boxes. The red stuff tends to be what will be more, I say interactive, but it's really not interactive as in a human's typing it. It's more, you probably don't want to kill processes at random. It's more when part of your automation or you decides to do these commands, usually that's when you will activate them. Now, I kind of showed all these events, and some of you may have been, pretty astute and saw that, file creation and file deletions in there. Hopefully, your EDR doesn't send every file creation and file deletion back to your backend because that's a whole lot of data. So what we do is we're a bit more intelligent. The sensor will record everything that's going on, all of the events, everything that's going on your box will get recorded in memory in a ring buffer, so to a certain amount of memory. The sensor will send a subset of those events. So you might say, I want all process creation to always come back to my backend where I can have a look at them in a database. You can choose which events you want to always come back. But more interestingly is you can actually go and say, programmatically, automatically, have a detection say, hey, something's going on this box. Give me everything that happened, everything that you've got from that box, all of the events that were generated, and send those back to me so that I can actually have a look at what was going on while maybe this box got exploited. And finally, you can even from the backend say, not only do I want these events, but for the next, I don't know, minute or X amount of time, I want you to start sending to me all file I/O. I know this is a crazy amount of data. Just for the next minute, because I think it's Recon from some hacker, and I want to keep track of what's going on, so I want to get this live. Now, I talked a lot about kind of capabilities and really kind of hand-wavy way. This is just kind of an overview of what are capabilities. What can you actually do easily with LimaCharlie? The main three ones are on the right side. So you have detections, hunters, and models. And I'll kind of go over it to show what it means. Essentially, events come from your sensors to the backend. They get fed to detections. So that's where you're going to detect stuff. And if a detection gets generated from this, it's an event, you can have a hunter, which is an automated piece of code, super simple Python, that can handle this and say, hey, I see there's process hollowing going on this box, or there's some kind of injection going on. I know how to investigate this, and it will go through essentially your Python and investigate this and produce a report. I'll get into all those. So first part, the modeling. Modeling essentially means that all the data that comes back, we put in Cassandra, which is our scalable storage, in a way that allows you to answer both through the web UI as well as programmatically in one of your hunters, for example, questions like these. So what are all the hosts where I've seen this hash? Pretty basic. Where have I seen process LSAS start iExplore, which would be odd. So those relationships get kept. So you can see all the hosts when it happened. Where have I seen LSAS connect over port 443? Or what percentages of hosts have seen WinINet loaded in Notepad? So these are all examples of relationships around objects. Essentially in objects, everything you can think of. And you're able to get statistical information and where different things have executed. Second part of the model, another part of the model is the crawling. Crawling allows you to do something like this. What it means essentially is that every single event we get from the sensor has a relationship to other events. So when a process gets created and a module gets loaded, the module is related to the parent. When a connection over the network is created, it's related to the process. All of this is available to you both via the web UI. So when you're investigating, you can say, I want to zero in on this process, and I want to see all the files it has accessed, all the, the DNS requests, the TCP connection, everything you want. You can also do this programmatically. So if you have this great idea of how to investigate, process hollowing, you can actually go and programmatically say, well, I'm going to take the process where I've seen a hollowing, and I'm going to look for any documents that it has written to disk, and then programmatically go through those, and maybe you want to fetch those files and things like that. File caching. File caching is pretty interesting. One of the common problems that we get when we're investigating stuff is the self-delete aspect of it. So maybe you get hit by some kind of PowerShell, and by the time that you've determined that this PowerShell execution was bad, well, everything's over because they've self-deleted, they've installed, their bootstrap in the system, and they've injected into everything. So what we do is, anytime there's a file that gets created on the system of certain types, not every file, we're not crazy, but of a certain type, which again, you fully choose, we're going to keep a cached version in memory, again in a ring buffer. And we are going to generate a stub event that says, hey, I've seen and I've cached this file. Now, what that means is when we do that in the sensor, now we're in the cloud and we say, hey, holy shit, I've seen, what is this example, right? A Word document was opened and it spawned ipconfig. This is bad. Well, the Word document's not there anymore. I think it had an exploit somewhere in it. I would sure like to get it. Well, from the backend, you're able to do a very simple document get with that file. And you're able to actually go and retrieve that document or that PowerShell script or batch file or exe or DLL or whatever it is. So that allows you to not always be like catching up to whoever got on your network. And who hasn't had one of those alerts where you're investigating, something's weird, you get on the box, you look at it, you can't find anything. Well, are they on there? I don't know. Maybe, maybe not. And realistically, everybody else got work to do, so they'll move on, right? Well, with this, actually, you're able to go back in time and really go to the bottom of it. Now, the interesting part, automated hunting. So in this example of automated hunting, we're looking at detecting Recon. So that's the first part. That's a detection that we're going to create. That detection uses stateful detection. Essentially, what that means is we have a way of a simple framework that in Python, very easily, you can correlate different events coming in from a sensor and generate a detection based on that. You can do that in the cloud, in the backend. You can also do that in the sensor if you really, really want to. So in this example, what we're going to do is we're going to say, if I see more than 3 processes in the list, ipconfig route, our ping trace route, start within 5 seconds of each other, this looks like this might be a recon script that somebody got in the system and just executed, because nobody does these commands in a row so fast. So that's my theory, that's my detection. So that's what that would look like. So I won't spend much time on it. The bottom line is it's really, really simple. Everything's been simplified so that it gets to the core of what you need when you build a detection. Step 2 is the investigation. That's moving into the part that very few that capability doesn't really exist a whole lot out there. So essentially, the investigation is done by a hunter. So now, right, we've detected recon. We've sent that to a hunter. The hunter says, oh, I've seen, like, I know how to investigate recon. So here's an example. You know, don't hold me to the fire to this. It's a quick example to show the capabilities. But maybe I want to go and I'm going to crawl up and find the common ancestor of all these recon processes. And then I'm going to keep going up in the parent of that process until I find a process that's been seen on less than 20 hosts. I'm looking for something that's rare. Maybe it's an exe that got dropped. If there's no unknown process, then, well, maybe that means that somebody's injected into that parent process, that common parent process, and from there they're spawning their recon. So I'm going to list the memory, dump any unknown memory. So I'm going to look in that memory map for read, write, execute. That's not a file. I'm going to dump that memory. I'm going to look for file paths. So all of this is inline in one Python script, and it's executed in real time from the backend to your sensor. I'm going to look for all the domain names. Then I'm going to, query those onto my thread feed, or I'm going to diff those against Alexa because I don't want to see google.com in that list. However, if there is an unknown process, then maybe I want to fetch the file and send it to VirusTotal. The bottom line is things like VirusTotal, Alexa, your thread feeds are all integrated in the backend so that they're essentially a one-liner from your hunter in Python. Very, very simple to query and just move on. Step 3, well, let's say mitigation. Again, it's a basic example, but it's to show you the idea. I'm going to suspend the process at the origin of the activity. It works probably better if you know that it's a rare exe that's likely bad. You probably don't want to suspend LSAS or try. But essentially, you can go and, again, your hunter can get to the point where it's made the conscious decision, this looks weird, it's not anywhere else on my fleet, VT says it's bad, look, like this process is bad. I don't want to wait 5 hours until the SOC guy wakes up in the morning and gets to his console. Screw this, I'm going to suspend the process right away. So that's what that is. It's a one-liner with a description of why you did it. And the why you did it is there because what you get as an output from a hunter is a report. So the detection gets generated. The hunter that runs essentially is an analyst, right? It's a virtual cyber analyst. Sorry, I had to. And they assemble together some kind of report, right? So they'll say, okay, I've looked if the process was known. And they will say, I've issued this command for this reason, and I got this data, and no, it's unknown, right? So you can generate this. Essentially, what you can do is you can have your people that are more experts, or people that have generated those hunters somewhere else online in other companies, create a predictable report of an investigation of this is what you do when you find process hollowing, and get a nice report out of it that you can then go through the UI and navigate or send to your SIM. You can also just jump onto the command line interface. So all of those taskings that you can send to the sensor, you can actually also do them through a command line interface. So if you say, okay, I know what I need to do, I want to sit down and start issuing commands to the sensor to investigate this, absolutely. Finally, you can load capabilities from GitHub now. So LimaCharlie's gone through quite a bit of a change. Now, one of those changes is that you're able to, through the web UI, say, I want to load this hunter and that detection from this GitHub repo. Really, it's any URL. And load those dynamically into your backend, into your server, and have those executing and searching your data as it comes in and just going. So we have a separate repo now just for those detections. Feel free to fork it. So that's it. I obviously encourage you to try it. It's on Ubuntu server, a one-liner install, very, very basic way to install it. It comes with pre-built sensors that will key your own sensors for Windows, OS X, and Ubuntu. So you don't have to like build some C stuff that is problematic. You just get those pre-built binaries and you're able to go and deploy them in the infrastructure with your own keys. Nobody else can actually interact with those. And if you need help, there's Slack, Twitter for news, or the website. Thank you.